In this video, let's go ahead and practice finding the sum or difference for each of these radical expressions together. So for sum and difference, we're going to be adding and subtracting some different radicals here. Now the radicals in this particular practice set is just going to be dealing with square roots. There's no cube roots or anything else, just going to be square roots here, okay? Make sure that we are sure to try and simplify or SimpLEEfy any radicals along the way to make things a little bit easier. All right, let's jump right into number 1. So for number 1, we have 9 times the square root of 2 plus 4 times the square root of 2. Now what's really nice about this first example is that these two radicals are identical. So if they are identical, that means we can just go ahead and add these two expressions together, and we can take a look at the coefficients here. So the coefficients are 9 and 4. So if we're going ahead and adding these two things together, essentially 9 plus 4, that's going to be 13. So we're going to have 13 of these square root of 2s. So 13 times root 2 or 13 root 2 would be the most simplified expression. Here's number 2. So for number 2, this one's actually quite similar. So let's appreciate the good things that we have for these first few. We have the square root of 6 and the square root of 6. And now in front of these radicals, we have the 5 and then we have minus 2. So 5 minus 2 means we're going to have 3. We're going to have 3 of these square root of 6s. So 3 times the square root of 6 would be the most simplified expression. All right, here is number 3. So for number 3, this one's the first time it's going to be a little bit different. Now notice we have this smaller number inside the radical of 2, so we actually like that one. The one that's a bit more of an issue right now is the square root of 18. It's always going to be the one that's larger. So we have to go ahead and see if we can break this 18 down into some smaller pieces. Now keep in mind that 18, what is 18 equal to? 18 is the same thing as 2 times 3 times 3. And every two prime factors that match make a perfect square. So if that's true, then these two numbers over here of 3 and 3 are going to make a perfect square. So 18 is going to be the same thing as 2 times 9, right? So if that's the case, then the square root of 18 is going to be equal to the square root of 9 multiplied by the square root of 2. So remember, you can multiply two radicals or two square roots to get a same product or value that's going to be inside. So we have 9 and 2 multiplied together to get 18. So you can break it apart like this. Now, what is the square root of 9? Well, we know it came from 2 3s, so it's going to be 3 times the square root of 2, or 3 root 2. Right? So that's what the square root of 18 is the same thing as. So let's go ahead and just go ahead and rewrite this a little bit. So we have this 4 and we have this 3. So I'm just going to go ahead and write this for now as 4 times the square root of 2. I'm going to leave this alone over here for a moment. And then I'm going to go ahead and add what? We're going to add this 3. That's a coefficient here. And what did we just say the square root of 18 was? We said that's going to be 3 root 2. So let's go ahead and multiply this by 3 root 2, just like this. All right, so notice how we have these root 2s that actually match, so that's really good for us. And then if you have these two numbers here, we can just go ahead and multiply those two together. So rewriting this, we're going to have 4 times the square root of 2 plus, and then what happens if you go ahead and multiply this 3 and 3 together? That's going to get us 9, so that's going to be 9. And then we have this root 2. Now that's the same thing as this one here, so I'm actually going to just change the color so they match. So we have 9 times the square root of 2, or 9 root 2. All right, so this works out really nicely. So we can go ahead and add this 4 root 2 plus 9 root 2. If we go ahead and add those coefficients together, 4 plus 9, that's going to be 13. So we're going to say this is going to be 13 times the square root of 2, or 13 root 2. So this would be the most simplified expression. Let's try another one. Here is number 4. All right, so just like in the last example, let's look for the radical with the smaller number inside. That's going to be the square root of 2. On the other hand, we have the square root of 32, and that's not the same thing. So we can't add or subtract right now. But let's see if we can go ahead and break this 32 down and make it a little smaller. Right? So this 32, if we go ahead and break it down into its prime factorization, it's going to be 2 times 2 times 2 times 2 times 2. It's 5 of these 2's, right? If we put 2 of these 2's together, that makes a perfect square, and another 2 2's together, that makes another perfect square. So 2 times 2 is going to be 4, 2 times 2 is going to be 4. 4 times 4 actually becomes another perfect square, which is going to be 16, right? So instead of saying all these 2's, we can say 32 is the same thing as 16 multiplied by 2, where 16 is a perfect square. So that means that we have the square root of 32 must be the same thing as the square root of 16 multiplied by the square root of 2, right? That's another way of saying that. Now the square root of 16 is 4, as we just kind of mentioned, so that's going to be 4 times the square root of 2. So the square root of 32, SimpLEEfied, is 4 times the square root of 2. All right, let's go ahead and rewrite this here. So we do have these numbers in front multiplying by these radicals. So I'm going to go ahead and take this 3. Let's go ahead and keep this as 3 root 2 for a moment. And we're going to go ahead and take away a 2. So minus 2. And then what was the square root of 32? We found out it's going to be 4 times the square root of 2. So let's go ahead and multiply this by 4 times the square root of 2. All right, so this one kind of looks similar to the last example here. Let's going to go ahead and just copy this 3 root 2 first. And then let's go ahead and just multiply this 2 times 4 together. That's going to be 8. So let's go ahead and write minus 8 multiplied by the square root of 2. All right, now at this point we can see that we have these 2 root 2's that match, so that's good for us. So I'm going to go ahead and rewrite this. I'm going to say 3 times the square root of 2, and I'm going to say minus, and it's going to be 8 times that square root of 2. Just go ahead and make those colors match so we know we can add or subtract these. When you do this, we just have to do 3 minus 8. 3 minus 8 is going to be negative 5. So our most simplified expression is going to be negative 5 times the square root of 2. All right, just like that. All right, here is number 5. For number 5, this one looks kind of similar to the last one. Notice right away that we have a smaller radical of this root 3, and then we have this other one that's a little bigger, this 27 over here. So we would like these to match if we were going to add these together. So let's see if we can rewrite and figure out what 27 is made of to break it down a little bit, right? So if we have 27, 27 is the product of 3 times 3 times 3. So again, if you have 2 matching factors, prime factors, that's going to make a perfect square. So 3 times 3 is going to be 9. So 27 is the same thing as 9 times 3. All right. So that means that the square root of 27 is just going to be equal to the square root of 9 multiplied by the square root of 3. Now the square root of 9 is going to be 3. So the same thing as square root of 27 simplified is going to be 3 root 3. So these two expressions are equivalent to each other. All right. So we have this 5 and this plus 2 here. So let's go ahead and just start writing this. We're going to have 5 times the square root of 3. We're just leaving that alone for now. And we're going to say plus 2. Again, we're not touching that yet. But what is the square root of 27? We said that's going to be 3 root 3. So let's go ahead and multiply this by 3 times the square root of 3. All right, so at this point we do have root 3 and root 3, which is really nice. Let's go ahead and multiply this 2 times 3 together so we can just make this look a little bit cleaner. So we have 5 times the square root of 3 plus, and then that 2 times 3 is going to be 6. So it's going to be 6 times the square root of 3. And now notice these square root of 3's do match, which is really good for us. So we can go ahead and clean this up even more. So 5 times the square root of 3 plus, and then we have 6 times the square root of 3, so 6 root 3. And now that these match, we can go ahead and add. So 5 plus 6 is going to be 11, so we're going to have 11 times the square root of 3, or 11 root 3. All right, this would be our most simplified expression. All right, here's number 6. All right, for number 6, we have negative 2 root 20 minus 2 root 5. Let's go ahead and identify which one is a smaller radical. So we have the square root of 5 here, so that's the one we're going to want to try to match. We have the square root of 20 over here, and that's the one we want to try to break down or simplify that radical. So what's 20 made of? Well, 20 is made of 2 times 2 times 5, right? That's its prime factorization. Now these two matching prime factors, 2 times 2 is going to be 4. So 20 is the same thing as 4 times 5, right? Where 4 is a perfect square. So that must mean that if you had the square root of 20, we could also rewrite that as the square root of 4 times the square root of 5. Now the square root of 4 we know is 2, so that's going to be 2 root 5. That's the square root of 20 if we go ahead and simplify it fully. Okay, so let's go ahead and rewrite this. So we do have this negative 2 in front, and we have this minus 2 here as well. So rewriting that, we're going to have negative 2 multiplied by, and then this root 20, we know we're going to replace that with 2 root 5. So I'm going to go ahead and substitute that in. It's going to be 2 times the square root of 5 minus, and then we have 2 multiplied by the square root of 5 over here as well. All right, now moving on, let's go ahead and multiply this negative 2 and positive 2 together. If we do that, we're going to get negative 4. So we're going to get negative 4 root 5 minus this 2 root 5. All right, And now notice how these two root 5s match. So we can actually go ahead and add or subtract these two pieces together. So we have negative 4 times the square root of 5. Let's just make those colors match here. And then it's going to be minus 2 times the square root of 5, just like that. Now if we take this negative 4 and take away 2, that's the same thing as negative 4 plus negative 2. That's going to be negative 6. So this is going to be negative 6 root 5, or negative 6 times the square root of 5 for our most simplified expression. Let's try another one. Here is number 7. All right, for number 7, let's take a look at our radicals. It looks like we have a smaller radical of the square root of 7, and then we have this larger radical of the square root of 63. So let's deal with this just like how we did in the previous ones. Let's break down 63 if we can. So 63 breaks into 9 times 7, but 9 is 3 times 3. So I'm thinking 3 times 3 times 7 would be 63. Now combining two of these matching prime factors, 3 times 3 is 9, which is a perfect square, so we have 9 times 7 is 63. That means if we had the square root of 63, we can also think about that as the square root of 9 multiplied by the square root of 7. Now the square root of 9 is 3, so this is going to be 3 root 7. All right, this is the same value as the square root of 63, just a simplified radical here. Okay, now let's go ahead and take a look at the rest of this expression. So we have 10 plus 2 essentially of these things that we're counting. So let's go ahead and just copy down this 10 root 7 first. So 10 times the square root of 7, and then plus, we're gonna have 2 of what? 2 of these root 63s. But what do we know that root 63 is? We know that's gonna be 3 root 7. Let's go ahead and multiply this by 3 times the square root of 7. Now it's really nice these square root of 7s do match, but we'll deal with that in just a moment. Let's go ahead and just multiply this 2 times 3 together. So let's copy down this 10 root 7, and then this 2 times 3 is going to be 6. So let's go ahead and write plus 6 of these root 7s. Okay, now these root 7s do match, which means we can add or subtract these two if we needed to, and in this case we're going to be adding. So we have 10 root 7, and then we're going to go ahead and add on 6 more of these root 7s. All right, so 10 plus 6 is going to be 16. You can think about them as coefficients if that helps you a little bit. So that's going to be 16 times the square root of 7. All right, here is 8. For 8, we have the square root of 15 minus 6 times the square root of 60. Now, which one is smaller? Well, the smaller one is the square root of 15. We want to leave that alone. The one that's bigger is the square root of 60. So let's see if we can deal with this square root of 60 part, right? So what is 60 made up of? Well, 60 is the same thing as 2 times 2 times 15. That equals 60. And now if you combine this 2 times 2, that's going to get us a perfect square of 4. So we're saying this is 4 times 15. That would be 60. Now the square root of 60 then, we can also break up into saying it's a square root of 4 times the square root of 15. The square root of 4 is 2, so this is going to be 2 root 15. All right, so when we look at the square root of 60, that's the same thing as 2 root 15. So let's go ahead and plug that into what we have earlier. Now, if we take a look and see also what values we have in front here, we have an invisible 1 that's in front. I'm just going to go ahead and write that so it's very clear. And then we have this minus 6. So I'm just going to go ahead and write the 1 just to be super clear. So we have 1 multiplied by the square root of 15. So we have 1 of these root 15s. And let's go ahead and take away, we have 6 of these root 60s, but what is root 60 the same thing as? It's 2 root 15. So we'll go ahead and multiply this by 2 times the square root of 15. All right, just like that. Now let's go ahead and multiply the 6 and 2 together. So we're going to have 1 times the square root of 15. That's first, just copy that down. Minus 6 times 2, that's going to be 12. So that's going to be 12 times the square root of 15. All right, so we do have 1 of the square root of 15 over here. And how many of them are we taking away? Well, it looks like we're taking away 12 of these root 15s. So 1 minus 12 is going to be negative 11. So I think we're going to have negative 11 of these root 15s after all. So this would be the most simplified expression. All right, where's number 9? Let's give this one a try here. Both of these numbers actually seem a little bigger. And so in this case, if you see these numbers a little bit bigger, it might be a good strategy to try to make both of them smaller if possible, especially if one of them doesn't seem to be particularly very small. All right, so I'm going to take a look at this 32 first and see what we can do with it. Now 32, let's go ahead and see what that breaks into. I think we used 32 earlier actually. It's 2 times 2 times 2, that's 8, times 2 is 16, times 2 is 32. So these two 2's make a perfect square of 4, and these two 2's make a perfect square of 4. 4 times 4 together makes 16, which is a bigger perfect square. So instead of breaking them into smaller ones, we can say this is going to be 16 times 2, that is 32, and 16 is a perfect square. So if we're looking at the square root of 32, then another way we could write that is the square root of 16 multiplied by the square root of 2. All right, so that's what the square root of 32 can be broken into. And then in a more simplified version, we can say this is going to be 4 root 2, because 4 is the square root of 16. All right, so let's go ahead and replace this with this. And let's see what else we can do here. We can also, well, actually, let's go ahead and just write that first. So I'm going to take this 2 in front, say 2 multiplied by what? Well, the square root of 32 is this 4 root 2. So I'm going to go ahead and write 4 root 2. Okay. And then we have this minus what? Minus 3. So I'm just going ahead and just write that down for now and just keep it as a minus 3 here. Multiplied by what? Well, I think this one we're going to have to do something similar. So let's look at the square root of 18. Now, what does 18 break into? 18 is the same thing as 3 times 3, which is 9. 9 times 2 is 18. Now, these two 3's combined make a perfect square of 9. So this is going to be equal to 9 times 2. So if that's the case, then the square root of 18 is going to be equal to the square root of 9 multiplied by the square root of 2. The square root of 9 is 3, so this is going to be 3 root 2. All right, so the square root of 18 is 3 root 2. That's the same thing. So let's go ahead and replace this and say this is going to be 3 root 2. All right, so at the end of the day, looks like we got both of these radicals to be root 2, which is really nice. So let's go ahead and just multiply this 2 times 4 together. That's going to be 8. Let's go ahead and put an 8 outside here. And then we have matching radicals. So I'm going to just turn this into 8 root 2 here. And minus what? We have 3 times 3, which is 9. So I'm going to turn this into a 9 times the square root of 2. Alrighty, so at this point we both have root 2's, which is really good. So we have 8 of them, take away 9. 8 minus 9 is going to be negative 1. So we can say this is going to be negative 1 root 2. And another way we could write this is just writing the negative and then writing root 2. So it's implied that there is invisible 1 in front multiplying. All right, here is number 10. Number 10, the numbers are getting a little bit bigger again, so we might need to try a similar strategy as the last one. So let's go ahead and just identify the radicals here. So first we have the square root of 28. Let's kind of just deal with that part first. So what does 28 break into? Well, 28 is the same thing as 2 by 2 by 7, okay? And so this 2 times 2 together make a perfect square of 4. So I'm going to say that's going to be 4 multiplied by 7. So that means if you have the square root of 28, that can be the same thing as the square root of 4 times the square root of 7. The square root of 4 is 2, so we can say this is going to be 2 root 7. All right, so when you see the square root of 28, that simplified is 2 root 7. So let's go ahead and swap that in here. So we have negative 4 over here in front. Let's go ahead and write that down as negative 4. And we're going to go ahead and multiply it by the square root of 28, which we just found out is the same thing as 2 root 7. So we went ahead and simplified that radical. Plus, what do we have next here? Well, we have this 4, so let's go ahead and write this 4 in front. 4 multiplied by what? Now, this 112 is pretty big, so let's see if we can break this 112 down. Okay, so 112 is definitely a bigger number. Let's go ahead and see what its prime numbers are. So 112 is equal to, we can definitely divide it by 2. If you divide it by 2, that's going to be 56. 56 can divide by 2, that's going to be 28. 28 can divide by 2, that's 14. 14 can divide by 2 is 7. So I believe we're going to have 4 of these 2's and then 1 of these 7's. Okay, so 2 and 2 together make a perfect square of 4. 2 and 2 make another perfect square of 4. 4 times 4 make a perfect square of 16. So this 112 can be the same thing as 16 by 7. Okay, so that means if you had the square root of 112, which is what we have here, we can say that's a square root of 16 multiplied by the square root of 7. Now, the square root of 16 is just 4, so it's going to be 4 root 7. All right, so if we have the square root of 112, we can say that's 4 root 7. So let's go ahead and replace that here and say this is going to be 4 root 7. All right, cool. So we do have these matching radicals of root 7. So let's just go ahead and multiply -4 times 2. That's going to be -8. So we're gonna have -8 and we have matching radicals. So I'm just gonna change the color here. So it's -8 root 7 plus, and then we have 4 times 4, that's gonna be 16. So that's gonna be 16 times root 7. All right, cool. So we have root 7 and root 7. Now we just go ahead and add -8 plus 16. -8 plus 16 is going to be 8. So this is going to be 8 root 7. All right, that'll be our most simplified expression. Here's number 11. For number 11, these numbers just keep seeming to get larger and larger. We might, again, need to have to simplify both of them. So let's just kind of start with this -7. Let's just go ahead and copy down the -7 here, leave that alone. And what are we going to multiply that by? Well, we have this square root of 160, which is a rather large number. So let's see if we can break 160 down. So 160, I know we can divide that by 2. That's going to be 80. 80 can divide by 2, that's 40. 40 can divide by 2, that's going to be 20. 20 can divide by 2 to get 10. 10 can divide by 2 to get 5. So I believe this is going to be 5 of these 2's and then a 5 here, because 32 times 5 is 160. Now 2 of these 2's make 4, 2 of these 2's make 4. There's no more matching pairs. 4 times 4 is going to be 16. So I believe here that we're going to get 16 from the first 4 2's, and then we're going to multiply that by 2 and 5. 2 and 5 make 10, right? So 16 times 10 is going to be 160. Again, we just multiplied the numbers that don't have pairs together because it's not a perfect square. So if we happen to see the square root of 160, which is what we have here, we're going to say that's the square root of 16 multiplied by the square root of 10. The square root of 16 is 4, so we can say this is going to be 4 root 10. This is going to be the most simplified version here. So let's go ahead and replace this square root of 160 with 4 root 10. So we can say 4 times the square root of 10 minus what? Well, let's take a look. We have this minus 2 here. So let's go ahead and just copy down that minus 2. And that's going to multiply by this square root of 90. So just like we did earlier, let's take this 90 and see what we can break it into. So 90 is the same thing as 3 times 3, that's 9. 9 times 10 is 90. So 10 breaks into 2 and 5. Now the only matching numbers here are 3 and 3, which makes 9. So I'm going to say this is going to be 9. The 2 and 5 don't have partners, so just multiply them back together to get 10. And so 90 is equal to 9 times 10. Also known as, if we had the square root of 90, that's going to be the square root of 9 times the square root of 10. The square root of 9 is 3, so the square root of 90 is 3 root 10. All right, so these two are equivalent expressions. So let's go ahead and swap this root 90 for 3 root 10. All right, just like this. All right, so it looks like we do have matching radicals, which is really nice. Let's go ahead and multiply what's in front. So -7 times 4, that's going to be -28. And then I'm going to change this color of root 10 to this color here, as we've been doing in the past, minus. And then 2 times 3, that's going to be 6. So it's going to be 6 times the square root of 10. All right, perfect. We have matching radicals. So if we have -28 and we're going to take away 6, -28 minus 6 is going to be -28 plus -6. That's equal to -34 root 10. And that would be our most simplified expression. All right, here is one final practice problem, number 12. For number 12, we are venturing into even higher numbers. So let's see if we can handle something like this. Let's just go ahead and take this 8 and copy this down. What are we going to multiply it by? Well, let's take a look at this 45. Let's see if we can break this down at all. It's always good to check, right? Let's take this 45. 45 is the same thing as 3 times 3 times 5. Okay, and so notice how we have 2 matching pairs, or 1 pair rather, but 2 matching numbers. 3 times 3 is 9, so we can say this is equal to 9 times 5. So if that's the case, we have the square root of 45 is equal to the square root of 9 times the square root of 5. The square root of 9 is 3, so this is going to be 3 root 5. All right, so we know the root 45 is 3 root 5. So replacing that over here, we're going to say this is going to be 3 root 5. Let's go ahead and take away what? Let's take away this 9. So let's go ahead and write minus 9 here. and 9 is going to have to multiply by whatever this square root of 245 is. So let's take a look at the square root of 245. Let's see if we can break that number down. That's pretty big, right? So we have 245. We know it's divisible by 5. So if we go ahead and divide it by 5, I believe that's going to be 49. And 49 breaks into 7 times 7. So it's actually quite nice here. But these two 7s together are going to make a perfect square. So that's going to be 49. So it's going to be 49 times 5. That's 245. So if we had the square root of 245, then that's going to be equal to the square root of 49 multiplied by the square root of 5. Now what is the square root of 49? That's 7. So it's going to be 7 root 5. This right here is the most simplified version of this. So let's go ahead and swap that out here. So this is going to be 7 times the square root of 5. All right, lovely. We do have matching root 5s here, which means we can continue. Let's do 8 times 3. That's going to be 24. So we're going to have 24 multiplied by root 5. Let's go ahead and change that color to what we've been using. Minus, and then we have 9 times 7. That's going to be 63. So it's going to be minus 63 root 5. And finally, if we take this 24 and take away 63, 24 minus 63 is going to be negative 39. So we're going to have negative 39 root 5. All right, so there you have 12 different practice problems where we went ahead and added and subtracted radicals. Keep in mind, we can only add and subtract radicals if they have the same base or same number inside the radical. And our goal is really just to go ahead and see if we can simplify each of the radicals, see if we can get some matching numbers inside there, and then add and subtract how many of them or the number in front of each of those radicals. So hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.